Alright, so Unit 9. Unit 9 was all about two proportions. We started the unit on February 13, and we started talking about confidence intervals with two proportions. That homework that day was page 508, numbers 4, 6, and 8, and you completed the first page of your packet, which was looking at what kind of inferencing techniques to use. Whether or not to use a one proportion confidence interval or hypothesis test, or a two proportion confidence interval or hypothesis test. I did do a video of this whole lesson, so I'm actually going to also upload that video to YouTube so that you can access that if you would like. We went over the formula, which was the estimate, where you take the two samples and subtract them. You find the critical value from the confidence interval using inverse norm, and then you calculate your standard error with both proportions using this formula. You also have to make sure that you state all of your conditions for confidence intervals, simple random sample for both, independent samples for both, population for both, and n times p for both p1 and p2. Templates are going to be the same, and if you are having trouble remembering the steps, I did go over the acronym for this, PANIC, which P is state the parameter of interest, along with what you want to do with the confidence interval. And then the A, which is assumptions and conditions. And then the N, which is name your test. And then the I, which is find the interval using the formula from the previous page. And then C, which is your conclusion, which is restating the interval and the confidence level. Okay, so again, for a confidence interval, you panic. Now, as far as the formula is concerned, you saw this confidence interval statistic plus or minus critical value times the standard deviation of the statistic. So you're not given that direct formula, which was this one here. But you can kind of get that formula from this. So in this case, your statistic is not just one proportion, it's actually two. So that's where you have to find the estimate and subtract them. You also are going to use the critical value, the same as before, that's your z-score. And then your standard deviation of the statistic is actually, since you are now in two proportion or two samples, you would then use this formula right here, which is the P1 times 1 minus P1 over N1 and P2 times 1 minus P2 over N2. So you can get the formula from your formula sheet, it's just not directly given to you. Okay? We then went through the example with the confidence intervals. You have two examples in your packets for that, and again I'm going to post the video from this. Now, as far as your calculator is concerned, it is a good idea to look at your calculator, go to Stat, arrow over to Test, and go down to two proportion Z intervals. And I'm going to go ahead and show you that on the calculator. Okay, so that would be press Stat, arrow over to Tests, and for a confidence interval, we're looking at two proportion confidence intervals. So it's this option B, which is 2 prop Z int. Okay? So that was confidence intervals. On Valentine's Day, the February 14, we did continue the two proportion confidence intervals. We looked at an example for warm-up, which we continued for the exit card. But we did also have two multiple choice questions, and if you want to go ahead and read this problem right now, and then you want to pause it and solve it, I'm going to pull up the answer in just a second. Okay, the answer to this problem was C. Okay, the correct answer, because 0 is not in the interval, it is unlikely to be true that the difference between the two proportions. 3 is just plain wrong, it's not a probability, and you cannot make a probability statement with an interval. So in this case, the correct answer was C. that it is unlikely the two populations have the same proportions, and you're 95% confident that the true difference between the population's proportions is between 0.07 and 0.19. The confidence level is not a probability. And then we have this multiple choice problem. So if you want to go ahead and read that. And for this one, the correct answer is D. Okay? That was put in your grade as well. Alright, we then took some class data and we looked at the classes proportions. That was that activity sheet that we did with males versus females, the cats, and the liking video games, and you completed that for homework. This was the free response question that I actually handed you back today, which today is Friday, February 22nd, and we went over this problem as a class and talked about what we needed to see in a confidence interval, which was all those things that I just talked to you about in my previous video. Alright, we then went on to talk about testing two claims with a proportion. Okay? And for this is called a two-proportion hypothesis test. We talked about how for this one, you do still have p hat, but in this case, p hat is a pooled. This is called pooling. Okay? So you do have to pool the two samples, because in your standard error, you actually have to use the pooled sampling. Okay? So you still have your first proportion, you subtract your second proportion, and for this one you're actually finding the z-score, because eventually you are going to be finding a probability and comparing that to your significance level. So conditions are still the same, they haven't changed for both, don't forget that. And then looking at the formulas, same thing as our previous confidence interval. We want to make sure that, again, this is your standardized test statistic. That's the z-score. So this z-score right here, that is your standardized test statistic. So you want to take your statistic of your first proportion and subtract the statistic of the second proportion, and then your standard deviation of the statistic, since you are in two proportions, is actually right down here. It may look a little bit different, so if you compare this formula at the bottom and this formula here, you can see that they're a little bit different. It's just that the square root is over the whole thing here, where it's over each piece. It's actually the exact same thing. Notice this says p and this says p hat, because remember we're using the pooled sample in this case. There is no true p-value that we're actually solving for, because we are looking for the difference in the two proportions. Okay? We then did several examples. Example 4, and then example 5 was your homework. That was part of your notes. And then we talked about what I should see in the conclusion of your hypothesis test. Some of you are still having problems with that. So in this problem, two types of medications for hives are being tested to determine if there is a difference in the percentage of adult patients' reactions, 20 out of 200, and then 12 out of another 200. You're testing at a 1% level of significance. So you need to make sure that you state the parameter of interest and the hypothesis. I'm sorry, this is the one where, okay, we state the parameter of interest and hypothesis. This is just a general hypothesis test without all of the steps for warm-up that we did. We did our Skittles activity, but it wasn't until a couple of days later that we went through, and this is where I was looking at the conclusion, and this was yesterday on Thursday the 21st. So we looked at the conclusion. Sally thinks that women do better in math than men. She takes a simple random sample, finds what her p-value is. What can she conclude? So the p-value, remember, is always the probability of getting your observed values from the sample if the null hypothesis is true. Okay? So in this case, there's a 50% chance, that's the probability of me getting what I got from my sample if the null hypothesis were true. You would then have to reject or fail to reject. In this case, I would definitely want to fail to reject since 0.5 is greater than my level of significance, which since it's not given, I use 0.05. And basically that means that I do not have enough evidence to move this up, move this over here. So I do not have enough evidence to suggest that, tie it right back to my problem, women do better in math than men. So if you fail to reject, you don't have evidence to support what you think. If you reject, then you do have enough evidence to say what you think. Okay? Then yesterday we played our review game, which we're going to go through these answers. If you want to pause it in between, type 1 error is when you reject the h sub 0, but you shouldn't have. A hypothesis test, the probability of obtaining R sample statistic or more or less, if the h sub 0 is true, is also known as the p-value. In this case, I want to pool them together to get 0.475. Since 0.01 is less than 0.05, we would reject h sub 0, so yes. In a two-proportion confidence interval, since I have a negative interval, that means that the second proportion would be bigger than the first. And then what is a critical value z asterisk use for 98% confidence? You want to take the inverse norm of half plus 50 of 98%. So half of 98 would be 49. So you're going to do an inverse norm on 0.99 to get that z value. Margin of error problem. So this is if they say the margin of error is this, what should I know, what would be the population? Since you have two N1 and N2, you would just assume that they were same and find what it would be for both of them. A type 2 error is when you fail to reject h sub 0, and you should have. If it is two-tailed, you multiply the p-value by 2. If p-hat is not given, you use 0.5. For two-proportion hypothesis test, at 0.05 level of significance, again, you're going to plug all this information into your calculator. So on your calculator, you would do stat, go over to tests, and this is a two-proportion z-test. There you would enter both proportions. X1 would be 54, N1 would be 98, and also for P2. And then you're concluding, since this is a left-tailed, you would select less than, and then hit calculate. You would then be able to get those results. And if the hypothesis would be h sub 0 is P1 minus P2 equals 0, and the h sub A is P1 minus P2 is greater than 0. Inverse norm of 0.05, you're looking at the z-score of negative 1.645, because statistically significant would be less than 0.05. And then for this problem, your h sub A would just be the difference of the two is greater than 0. And if you're not sure but you need to continue it, you use proceed with caution. And if you're doing a two-tailed, you would, is your result considered statistically significant? No, because a z-score of 1.6 would be a p-value of 0.005, which is greater than 0.05, meaning you fail to reject. And I'm just going to kind of go through these quickly. And you can pause at any point. We then reviewed today, check Edline for the review sheet answers, and good luck studying. If you have any questions, see me Monday morning.